This video lesson will focus on solving polynomial equations. Specifically, we will look at higher degree equations. Previously, we have studied quadratic equations and linear equations. They are examples of polynomial equations. Linear are first degree, quadratic are second degree. A polynomial equation is simply an equation of the form a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus all the way down to a sub 1 x plus a sub 0 equals 0. Don't be confused by all of that. That's really just saying that the left side of the equation is some type of polynomial of degree n. The a sub n's and such are the coefficients of those terms, and the x to the n, x to the n minus 1, those are the variable expressions. The degree of a polynomial equation determines the number of solutions of that equation. Just as we saw with a linear equation, they typically have one solution, though there are special cases of those contradictions and identities. A quadratic equation has a degree 2, and there are two solutions of those equations. To solve a polynomial equation, we are just going to extend the zero products property. That is, we get one side in a factored form equal to 0, and then we can set each factor equal to 0. Please note that the equations that we're doing in this section are factorable. There are methods to solve those types of equations that are not factorable, but those are beyond the scope of our course. Let me illustrate with an example. We want to solve the equation 8x cubed plus 4x squared minus 50x minus 25 equals 0. To solve this equation, we need it in standard form, that is, decreasing powers of x, and one side equal to 0. Then we will factor this polynomial that is on the left side. Because this polynomial has 4 terms, we will use grouping to factor. If we pair together the first 2 terms and the last 2 terms, notice that the first 2 have a 4x squared in common. Factoring out a 4x squared from 8x cubed leaves a 2x. 4x squared divided by 4x squared leaves a 1. And then we have a minus 50x minus 25. The common factor there is 25, but because of the negative sign separating this middle term, we need to factor out a negative 25. Negative 25 into negative 50x is 2x. Negative 25 into negative 25 is plus 1 equals 0. So now notice that we have a common binomial, this 2x plus 1, that we can factor from these two terms. We get 2x plus 1 times 4x squared minus 25 equals 0. 2x plus 1 is a linear term. We can't do anything more to that. 4x squared minus 25 is a binomial. That is the difference of two squares. We can factor this further to 2x minus 5 times 2x plus 5 equals 0. Now we have it factored equal to 0. We set each factor equal to 0 and solve. 2x plus 1 equals 0, 2x minus 5 equals 0, or 2x plus 5 equals 0. Subtracting 1 from the 2x plus 1 equals 0 gives us 2x equals negative 1. Dividing by 2, we get one solution to be negative 1/2. 2x minus 5 equals 0. We add 5 to each side to get 2x equals 5, and dividing by 2, gives us x equals 5 halves. Lastly, 2x plus 5 equals 0. We subtract 5 from each side to get 2x equals negative 5, and we divide by 2 to get negative 5 halves. The degree of this equation is 3, and notice that we have 3 solutions. In the solution set, we write negative 5 halves, negative 1 half, and 5 halves. You might also see this written as plus or minus 5 halves and negative 1 half. Another example is 5m to the 4th minus 5 equals 0. To solve this equation, notice that we have a polynomial, specifically a binomial, equal to 0. To factor this binomial, we first see that there is a common factor of 5. Factoring a 5 out leaves 5 times m to the 4th minus 1 equals 0. M to the 4th minus 1 is the difference of two squares. We can factor that to be m squared minus 1 times m squared plus 1 equals 0. Right, recall that m squared squared is m to the 4th. Now, m squared minus 1 is the difference of two squares, so we can factor that to be m minus 1 times m plus 1. However, m squared plus 1 is the sum of squares which cannot be factored. So we write this as 5 times m minus 1 times m plus 1 times m squared plus 1 equals 0. To solve this, we set the variable factors equal to 0 to get m minus 1 equals 0, m plus 1 equals 0, or m squared plus 1 equals 0. So remember, we're trying to find what values of m can we substitute into this equation to get a true statement. One of those values is positive 1. Another is negative 1. And then to solve m squared plus 1 equals 0, we apply the square root property. This gives us m squared equals negative 1. So to solve for m, we have that m equals plus or minus the square root of negative 1. The square root of negative 1 is the imaginary unit I. So our four solutions are 1, negative 1, I, and negative I. We can write these as plus or minus 1 and plus or minus I. Again, note here that our degree is 4, and we have 4 solutions to this equation, 2 real solutions and 2 imaginary solutions. For a third example, I want to solve the equation 5m to the 4th equals negative 5m. It's very similar to the previous problem. First note, we do need to get one side equal to 0. To do that, we're going to add the 5m to each side. This gives us 5m to the 4th plus 5m equals 0. Now we factor out a common factor. This time the common factor is 5m. Factoring out 5m leaves m cubed plus 1 equals 0. m cubed plus 1 is a binomial that is actually the sum of two cubes. The sum of two cubes has a pattern that we apply to factor. If we have a cubed plus b cubed, to factor this it is a plus b times a squared minus ab plus b squared. So the binomial factor comes from what do we have to cube to get the terms in the original binomial. Once we know the binomial factor, we need to apply this formula, if you will, to figure out what the trinomial factor is. We square the first term, do the opposite sign, and multiply the values of a and b. The last sign is always positive, and then we square the second term of the binomial. Some people remember SOAP when we're dealing with the sum of cubes or difference of cubes. SOAP stands for same, so it's the same sign first, then the opposite sign, and the last sign is always positive. So applying this to m cubed plus 1, back in our equation we have this common factor of 5m to come down. To factor m cubed plus 1, we think, what do we cube to get m cubed? And that is m. What do we cube to get 1? That is 1. So our binomial is actually m plus 1. The trinomial, we now square m to get m squared. We take the opposite sign and then multiply m times 1, which is just m. The last sign is always positive, and then we square the 1, and 1 squared is 1. So our factoring is complete at this point. The trinomial that we obtain from the sum of two cubes is not factorable. We will leave it in this form, and then we have to apply the quadratic formula or some other means to solve this equation. Setting each of the factors equal to 0, we get 5m equals 0, m plus 1 equals 0, or m squared minus m plus 1 equals 0. Divide by 5 to get m is equal to 0. Subtract 1 to get m equals negative 1. And then to find the two remaining solutions, we solve m squared minus m plus 1 equals 0 using the quadratic formula. In this case, the constant term, the coefficient of the m squared term, a, is 1, b is negative 1, and c is the constant term 1. So we find that m is the opposite of b, or the opposite of negative 1, plus or minus the square root of b, which is negative 1 squared, minus 4 times a times c, which is 4 times 1 times 1, all divided by 2 times a, or 2 times 1. Simplifying gives us 1 plus or minus the square root of negative 1 squared is 1, minus 4 times 1 times 1 is just minus 4, all divided by 2. We get m equals 1 plus or minus the square root of negative 3 divided by 2. Simplifying the square root of negative 3, we get 1 plus or minus I on the square root of 3 all over 2. So our four solutions are negative 1, 0, 1 plus or minus I on the square root of 3 divided by 2. One last example for the polynomial equations is to solve 2y squared times y squared minus 2 equals 18 plus y squared. So we need to multiply on the left to get 2y to the fourth minus 4y squared equals 18 plus y squared. To set one side equal to 0, we will subtract 18 and subtract y squared from each side. This yields 2y to the fourth minus 5y squared minus 18 equals 0. Now we will factor this. This is a trinomial. We can factor it using either the trial and error method or the AC method. The AC method says we need to find the factors of 2 times negative 18, which is negative 36, whose sum is negative 5. If we think about the factors of 36, first ignoring the signs, we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Because we need a negative 36, we know the signs have to be different. But for the sum to be negative, the larger factor needs to be negative. And the only way that we can get a negative 5 is from a plus 4 and a minus 9. So what that tells us is that has to be the outer and the inner product. The only way to get 2 is just 2 and 1, so we know that our first terms have to be 2y squared and y squared. The factors of 18, the only way to get a 9 and 4 in there are to use 9 and 2. So we have 2y squared with the 9 and then a 2. Because 2y squared and 2 gives us 4y squared, 9y squared for the inner terms. We know the factor of 9 needs to be negative and the 4 positive. 2y squared minus 9, y squared plus 2 can't be factored further, but these are quadratic factors, so we set each of those equal to 0. 2y squared minus 9 equals 0, or y squared plus 2 equals 0. Adding 9, we get 2y squared equals 9. Divide by 2 to get y squared equals 9 halves. So y is equal to plus or minus the square root of 9 halves. This is plus or minus 3 over the square root of 2. To remove the radical from the denominator, we can multiply the top and bottom by the square root of 2 to get plus or minus 3 on the square root of 2 over the square root of 2 times the square root of 2 is the square root of 4, or just 2. And then y squared plus 2 equals 0. We subtract 2 to get y squared equals negative 2. So y equals plus or minus the square root of negative 2, which is plus or minus I on the square root of 2. The 4 solutions then are plus or minus 3 on the square root of 2 divided by 2, and plus or minus I on the square root of 2.